Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 2 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a worker packing items in boxes here, and we have a linear relationship. Okay, if that helps us. So we're going to have a constant rate of change between the number of items and how long it takes, right? So 5 minutes gets you 20 items, 7 minutes gets you 28. So which statement describes the rate of change? Look at this big paragraph here. The number of items the worker packed in boxes with respect to. All right, so that's our first clue right there. With respect to is actually a connecting word. And we could replace it with per. So when I'm looking at the rate and per, this rate is very similar, kind of means the same thing as ratio. Hopefully we're thinking, all right, let's make a fraction. Let's make a ratio here. So what goes in my numerator? Well, the number of items the worker packed in boxes. So I'm just going to write items. And then the number of minutes the worker's been packing. So let's just write minutes. All right, so items, the ratio of items to minutes, and it's the rate of change. Okay, so I'm going to use this Greek letter delta, which represents change in math and science. It looks like a triangle. So the rate of change of items over the change in minutes. So let's label these variables, right? So this is my independent variable because how long I am using to pack these items is going to drive how many items I can pack. So that's my independent variable because my dependent variable, the number of items, depends on, well, how long I've been packing. So that means this is my domain or my x. My dependent variable is my range or my y. So really, my number of items is going to be, I can replace that with change in y. My minutes is change in x. So hopefully you're thinking, hey, that sounds familiar. We typically call that rise over run or slope. And if you are thinking that, you're correct. If we were to graph this, we would simply be looking for the slope. That's what our rate of change really is that slope. So how do we find that? Well, we just need two y coordinates, y sub 2 minus y sub 1. And then x sub 2 minus x sub 1. So that's it. We just got to find some coordinates and subtract them here. So let's just pick these first two. It doesn't really matter. Right? So let's say that's going to be my y1, y2, x1, and x2. Okay? So we will say that we've got y sub 2 is 28, y sub 1 is 20, it's my numerator, and then I've got x sub 2 is 7, x sub 1 is 5, looks pretty straightforward, 8 over 2, looks like 4, which is one of our answers. Okay, let's just double check. I want to try another pair. Let's say that this is my x sub 1 and my y sub 1. What if I do the extremes? What if I go make that my y sub 1 and my y? Let's make that my x sub 2. And let's see. We got to match these up. Make sure your x2s are across from each other and your x2 and y2 are across. My x1 and y1 are across. All right, so we're going to do 56. All right, this is my y sub 2 minus 20. And then my x sub 2 is 14 minus 5. That's my x sub 1. So that still gets me 36 over 9. Yeah, still equals 4. So you can come up with as many combinations as you want to. The rate of change is still going to remain constant because remember, it is a linear relationship. which means it has a constant rate of change. And the answer is going to be H. The worker packed 4 items in boxes per minute.